We talked about arithmetic sequences. We've kind of brushed up a little bit on geometric sequences. Phones away, please. Phones away. So arithmetic, we're adding. There's a common difference each time, right? Geometric sequences is a little bit different. For this, you have a constant ratio. This is geometric sequence. A constant ratio between consecutive terms. What's consecutive?
Right next.
In order. So this is always going to be what we call R, okay, for ratio. It's a constant ratio. It is your common ratio, we will say. Remember, we said common difference. That was adding and subtracting. Common ratio is going to be a ratio instead, where you are multiplying, or you could see it as dividing. Okay, so the way we come up with that ratio, the way that we're going to find our R, is we're going to take our a sub n, so whatever term we're dealing with, and we're going to divide it by the term right in front of that. So I'll show you in just a minute what that looks like, but here's how we would set that up. So if you're ever looking for R, you're going to take some term, so like the second term, and you're going to divide by the first term. Or you're going to take the fourth term, and you're going to divide by the third term. Okay, so divide by the term right in front of it. All right? So here's an example for you. First thing I want to know is this geometric, arithmetic, or neither? Okay, so I'm going to give you a sequence, a couple sequences, and see if you can tell me. So 5, 10, 15, 20, 25, and so on and so forth. If I take that, is that geometric, arithmetic, or neither? That's arithmetic. Why is that arithmetic? Right, every time you're adding 5, plus 5, plus 5, plus 5. So if you're adding the same thing every time, you have a common difference. That is arithmetic. Okay, what about this one? If I give you 5, 10, so it looks the same, right? Starts the same, but now we're different. What are you doing there? You're multiplying by 2 every time. So times 2, times 2, times 2, times 2. So what is that? That's geometric. If you're multiplying by the same thing or dividing by the same thing every time, that is geometric. So in this case, your ratio, your common ratio, your R, is 2. Okay, that's what that's saying. Whatever you're multiplying by is your R. What would this be? So you have 1, 2, 6, 7, 11, 12, ... That's neither, right? You can think of it like this. I'm going plus 1, and then I'd have to go plus 4. Or you could say, okay, well, it's not that. What if I multiply? It's times 2, but now it's times 3. If that number is changing, it's neither. Okay, so you can't add, you can't multiply, so we would just say this is neither. Okay? Okay, so I gave you formulas for the arithmetic. Now I'm going to give you formulas for the geometric sequences, a recursive and explicit. Like we said before, you will get all of these on the test. It just doesn't tell you what they are, but you'll see the formulas. The formulas will be there. You just need to know this is geometric, this is arithmetic. Geometric is always going to have an R in it. Arithmetic is always going to have a what? D for common difference. Okay, so that's how you can distinguish which one is which. All right, so here's the formulas for geometric. So starting with recursive, how does a recursive formula always start? A of 1. You want your first term. Okay, so you'll have A of 1 equals something, and then you'll have a sub n equals a sub n minus 1. Remember, they always start that way. A sub n minus 1. And now for geometric, we're multiplying by the common ratio. So we're going to go times r. Okay, so that's the recursive formula. The explicit formula, my x's always look like y's. Really sorry about that. The explicit formula looks like this. You will have a sub n equals the first term, a sub 1, times your common ratio to the n minus 1 power. Okay, now that should look somewhat familiar to you. Does anyone know what that looks like? What kind of formula? What kind of function? Exponential, right? This is an exponential function, right? Where normally this was our growth factor or our decay factor, but it looks just like that. Okay, so this will be exponential. Okay, so let's take a look. Using those formulas, if I give you 11, 33, 99, 297, ... Okay, we want the recursive and the explicit formulas for these. So let's start with recursive, right? We're looking right here. We're going to say, first of all, a sub 1 is 11, your first term, okay? So that's going to be the start of it. And then the second part of it, a sub n, is going to equal a sub n minus 1 times, and now we have to figure out our common ratio. And here's how you find it. I said this early on, right at the beginning of the lesson. You take the second term and divide by the term before it. So 33 divided by 11, or you could take the third term and divide by the term before it, 99 divided by 33. Either way, you get a 3 out of that. Okay, so any term divided by the term in front of it should be the common ratio. Okay? So what we're going to do with this formula then is we're going to put a 3 right there, and that is your recursive formula. So this would be your answer for recursive. Okay? Then we do explicit. So we're working right up here now. It's going to be a sub n equals, what goes here? 11 again, times, what's r? 3 to the n minus 1. Okay, so that would be your explicit formula. Question for you. If I said, find the 10th term, which formula makes more sense, recursive or explicit? Explicit makes more sense when it's not like the next term in the sequence, right? So if I said find the 10th term right now, we would plug it in to this formula. So a sub 10 equals 11 times 3 to the 10 minus 1 power. So 11 times 3 to the 9th power. And when you plug that in, you get the 10th term is 216,513. Okay, jumps up quickly, right? Because it's exponential. It's going to shoot up. All right. Example 3. We're going to do the same thing. Find the two formulas for this sequence. So we have negative 1,000, and then 100, and then negative 10, and then 1, ... Can you tell my difference? Tried to separate them a little more. So we want a recursive and an explicit. Let's start with recursive. What do you do first for the recursive formula? A of 1. What is A of 1? Negative 1,000. Okay. And then A of n equals a sub n minus 1. And now you have to figure out what r is, because this is times r, right? How do you find r? Divide. Right, so take a term. It doesn't matter which one. They will tell you this is a sequence, a geometric sequence. You just have to pick a term and divide by the term in front of it. So if I pick 100 and divide by negative 1,000, okay, that would be the same as if I did it right here, which is a whole lot easier, 1 and divide by negative 10. So negative 1/10 is my r. Okay. Either way, this reduces to negative 1/10, or negative 0.1 if you want to plug it in and you get a decimal. That's not the end of the world for me. You may use a decimal in that case. So we would say this is a sub n minus 1 times a negative 1/10. Okay, that's your recursive formula. Explicit. What are we going to do for our explicit formula? A sub n equals negative 1,000. So you start with the first term, negative 1,000. Then what? Your r. What's your r? Negative 1/10. Okay. And then what do you do with that? To the n minus 1 power. Okay. So if I'm finding the 15th term, what power am I taking that to? 14, right? 15 minus 1. You're just plugging in a 15 for n. Okay. Sorry. I'm losing it with my eye. Okay. Questions on that? I got 2 more types of problems here, and then we're done. 3 problems to do, 2 types of problems. So example 4, we're gonna write the explicit formula. If a sub 1 is 2 and r is 10, and then from that we're going to find the first 5 terms. Okay, so starting with writing the formula, a sub n equals, and now the information is there for you, it's just setting it up in the formula, which keep in mind you'll have the formula in front of you. When you do this homework, I would keep the formula in front of you, all the formulas, keep them right in front of you, okay, because that's how you'll take a test. So it's not cheating to have them in front of you. That's how you'll take it. What do we do here? 2. A sub 1 comes first, right? So it's 2 times what? 10. Times 10. Actually, I'm going to do parentheses here. 2 times 10 to the n minus 1 power. Okay, so that's the formula. And then we have to find the first 5 terms. So a of 1 is what? 2. It's already there for you, right? So we have our first term. A of 2. Okay, now here's the thing, guys. If you really stop and think about this, our common ratio is 10. What does that mean? It means we're multiplying by 10 every time. Okay, so you could right now just multiply by 10 every time. Or if you don't want to think through that, you could just do this. 2 times 10 to the 2 minus 1 power is 2 times 10 to the first power, which is 2 times 10, right? So this is 20. Okay. A of 3, you can do the same thing. 2 times 10. 3 minus 1 would be the second power. So 10 to the second power is 100 times 2 is 200. But again, you are just multiplying by 10 every time. So you're welcome to do that if you can see that. If you don't see it, then plug it into the formula. 2 times 10 to the, this one would be 4 minus 1, so the third power is 2,000. And then the fifth term, 2 times 10 to the 4th power is 20,000. So your sequence would be 2, 20, 200, 2,000, 20,000. That's your sequence. Okay, questions on that? Okay, last idea is this one. Geometric mean, and I taught you this in geometry last year if you had me for geometry. When we talked about geometric mean, if you remember, we set it up as a proportion. A over x equals x over b, and we cross-multiplied, and then we square rooted to figure out what the geometric mean was. That's what you're doing for geometric mean. It is the square root of the product of two numbers. Okay, so let's say I have this setup, example 5. If I tell you my sequence goes 20, something, 80, okay? Yesterday when we did this, we added them together and we divided by 2 because it was an arithmetic sequence. With a geometric sequence, you multiply them and you take the square root. So we're gonna go the square root of 20 times 80, and we get 40. Okay? But what if it looks like this instead? 19,683, 3 blanks, and then 243. Okay, so think back to how we did this yesterday. What do you suppose we should do right now to find those 3 missing numbers? Esther.
Oh, I'll find the middle term first by doing the
Right.
same thing.
So we're going to take these 2 numbers to find this one, right? So we're going to take the geometric mean, which means we're doing 19,683 times 243 and taking the square root of that. Okay, so when you plug that in, you get 2,187. Okay, this is 2,187. Then from there, now we're going to take these 2 and find the geometric mean. So that's going to be the square root of 19,683 times 2,187. Okay, plug that into your calculator. And you can plug it in just like that. Square root, and then this times that, and go from there. And your answer for that one should be 6,561. And then the last one, we're going to do it with these 2 numbers now. Okay, so the square root of 2,187 times 243. Plug that in, and you get 729. Okay? Any questions on that? Okay.